when keys are comparable and we can put them in order, we saw that we can use binary search to get an efficient symbol table implementation. But we can also provide a lot of convenient functionality for the client. That's what we're going to look at next. So this is just an example of an application that might try to associate keys with values, and an illustration of all the different operations that a client might want. So we already looked at the get operation, so we might want to know what city is associated with the event that happened at time 9:13. And so that should return that value. But there's plenty of other things that we might want. Like, for example, what's the earliest time? That's the min. Or what's the latest time? That's the max. What about being able to iterate among all the keys between two given times? That certainly is convenient. Then there's what's the seventh largest time? So that's select like the median, or it generalizes min or max. Which key happens second or seventh? So that's order statistics in our dynamic thing. What happened, what's the closest thing that happened just before 9:05? Certainly plenty of clients might want that. So this one is, I've only got 10 tickets to sell, so that's the cutoff point for selling, or 7 tickets, that's the cutoff point for anybody after that time doesn't get a ticket. And this one might be, if there's a time cutoff, I'm not going to sell tickets to anyone that came after that time. And then the corresponding one is, what's the first thing that happened after that time? That's call into the radio show. I'm going to take that caller, first call that comes at 9:30, and so forth. So then see how many things happen between 9:15 and 9:25. And how many calls were there before 9:10:25. So you can see that all of these operations are quite natural when we have the table in sorted order, and that's what we have for our binary search implementation. So we can implement these efficiently, and they are convenient and useful for the clients. So typically for ordered symbol tables, when keys are comparable, will provide a much wider interface. It's very useful for many clients. So we say that we're dealing with keys that are comparable by simply adding this extends comparable key to our declaration, same way we did for sorting methods. So all that means is our implementations can use compare to. But for the client, it means that all of these operations have meaning. Give me the minimum key, give me the largest key, and then I can get the value associated with that using get. Give me the largest key less than or equal to this key value, or the smallest key greater than that key value. Give me the number of keys less than that key. You can actually implement priority queues this way. Delete the minimum key, delete the largest key. Now, usually we argue against wide interfaces, just adding operations to an interface. But usually our reason for doing so is that we can't guarantee that all the operations can be performed efficiently. In this case, as we'll see, ultimately we have ways to guarantee that all the operations can be performed efficiently, and they're so convenient for clients, it's certainly worth adding them. So we have iterate through all the keys and iterate through all the keys in a given range, and count the number of keys in a given range. All of these operations are very useful for clients, and we'll see plenty of examples later on. So we have to greatly expand our table. What are going to be the costs of all of these things? And this is a big difference between the binary search implementation, where the keys are kept in order in an array, and the sequential search implementation when they're all in a linked list. So, for example, to provide ordered iteration, you have to get them sorted, and that's going to be a lot of work and take n log n time, whereas binary search, you just iterate through the things in order. Give me the seventh key, we just go and look there, they're in order. The rank operation, that's essentially what binary search provides. That's our basic implementation, is providing rank. Floor and ceiling, that's again an outgrowth of the rank operation. Minimum and maximum, well, again, those are like select, they're just right there. You look at the first or the last. To insert or delete, however, takes linear time. To maintain the sorted array in dynamic fashion is going to take linear time. You have to go through the whole thing. And so that's really the key to thinking about ordered symbol tables and symbol tables in general. How can we guarantee that all operations are fast? Binary search is pretty good, but that's a major flaw. I can't maintain a dynamic table efficiently with binary search. And that's going to be our focus in the next lecture.